Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. Hello, and welcome back to the first 2021 episode of the CBA Podcast, and thanks for tuning in. First, we'll talk a little bit about fluffy stuff like New Year's resolutions and stuff that I fixed. After that, there's going to be some stuff that I actually made, and some theory, maybe you like that, about ground loops. And that's basically it for this time, so let's go. So, New Year's resolutions. Some non-techy stuff for myself. I decided to use less plastic wrappings, plastic and other stuff for food, for example, because there's enough plastic as it is, I think. And for example, you can buy food in bulk, or you can buy food wrapped in paper, or other materials that are not as troublesome for the environment, or just eat less crap. That helps. So I'm gonna do that. Another non-techy stuff related to the previous one is I'm gonna clean up plastic and other crap that people throw out of their car and ends up next to the road, because I see a lot of that crap laying around here. There are cleanup events here. Maybe I'll post a link to one of those so you can register yourself and then just pick a date or something like that and clean up the crap in some part of the country. So we'll see how that goes. Some podcast and life related New Year's resolutions are, I'm trying to be a little bit less serious, because if I listen to previous podcasts of episodes of CBA Podcast and even previous videos that I recorded on YouTube, I try to sound so very serious, and everything I say is very important. Because I spent hours researching this stuff, and everyone should pay attention, which is of course a load of crap. So I'm gonna take myself a little bit less serious. I think I'm doing a good job already, but can be way better. So let's do that. Also podcast related. I'll try to get this thing on Spotify and Google Podcasts and maybe other aggregate sites or whatever it's called. Just to reach a bit of a wider audience. In between now and the previous episode, the only thing I fixed was my car. And I usually don't even bother trying to fix my car because I don't know anything about it. So, okay, in technical terms, you have one of these little stick things that you can use to enable the big bright light, the signaling light. And after 20 years or 25 years or something like that, it's been worn out. And it makes contact when I don't want it to make contact. So when I drive at night, I'm signaling people all the time, which is not really nice. So instead of actually fixing the problem, and by the way, I ridiculed occasional co-host Doman for this. I think he had a similar problem at some point, and he fixed it by taking out a fuse or bridging a fuse in his car. And that's exactly what I did. Take out the fuse for the bright light and fixed. So, so I think at the next test or something like that, I'll simply put back the fuse and then pass the test and then take it out again or something like that. So that's how I fixed the car. Take out the fuse. One completely different thing I noticed was when I had to script a little bit for work, using a scripting language, make a little program for someone. And I hadn't done that for a long time. And I noticed how much I like that and how powerful a scripting language actually is. I use Ruby for this kind of stuff now. I'm not proficient at it at all, but this is what I use. I like it. I like coding in it. And what I noticed a while ago, maybe you have the same, depending on whether you are more into software or hardware or neither or both. But depending on what I do, I notice that the time I can spend doing it before I get tired differs a whole lot. For example, writing software, for me, using a scripting language or an actual programming language like C, I can do that for 1 hour or maybe 2 hours, depending on what I'm doing, if it's complex or not, or if I like it or not. And then I need to take a little break. Something else I do quite a lot here is layouting PCBs, so placing tracks and placing components, placing zones and so on. I can do that for 45 minutes and then I absolutely need a break. and then it goes okay again. But if I do that longer for 45 minutes, there's no productivity at all anymore. That's pretty weird. Don't know about you, so if you have any comments or feedback, please let me know, because it's quite interesting, I think. And something else I do here every once in a while is making 2D CAD drawings, vector drawings, and an AutoCAD clone or something like that. I use QCAD here. And I think I can do that for a long time, because it's not difficult at all. It's sort of relaxing, and it's not difficult, and I don't know, I can do that for a long time. And even programmatically making visual stuff. For example, an OpenSCAD, which is basically a programming language generating 3D scenes. I can do that for a long time without getting tired. It's very strange. Like it doesn't place as big of a load on the brain or something like that. I have no idea. So please let me know what you think, because it's quite interesting to see what other people can do and like to do, and how long they do stuff. And the final fluffy item is a tip I got from a friend of mine, and I think he got it from a Make magazine, if I recall correctly. And it was, you can use one of these 3D printing pens, which is basically a pen with a hot nozzle at the end, and it ejects filament, just like a 3D printer, except it's a handheld 3D printer basically. So you use this thing to glue stuff onto a 3D model. For example, if you printed an enclosure that holds a PCB, you can place the PCB where it should go and then glue, apply extra filament using the 3D pen just organically where it needs to be, and then you can glue the PCB onto the enclosure. So maybe that's a tip for you. Usually I don't have one of these pens, so obviously I cannot try it here. I think it worked fine for him, if I recall. What I do here usually is use a lot of hot glue for everything. But maybe it's a tip for you then. The last episode I talked a little bit about a board I made a while ago. It was a VGA generator board. Essentially a microcontroller and a VGA connector, and you can connect a VGA monitor to the board and then treat the whole VGA monitor as one big RGB pixel. So no image, no graphics, just one color for the whole screen, and you can make effects or fade in or fade out and stuff like that using the code in a microcontroller. Some people suggested to extend this board with DMX512 or DMX512 or 512, still don't know how to pronounce it, sorry about that. So it can be used as a slave on a DMX bus. Now DMX is a protocol for controlling stage equipment essentially. For example, lights and lights with motors, movable lights, or motors or smoke machines or stuff like that. So that's what I did. I made a new board where the previous one had 4 VGA connectors to connect 4 monitors. This one has only 1, so it's only meant to be plugged into the back of one monitor or one VGA projector. I'll put pictures of this and also video of this I made. Put it in the show notes. And also for projects like this, I think I'll start putting schematics of it in the show notes. Except for this one, the schematics is really not that interesting. It's a microcontroller and a connector and some resistors, and that's essentially it. So I think for this one, I won't bother because it's not really interesting. But for other stuff, maybe yes. A bit about the protocol itself. It is a serial protocol with a RS485 differential serial bus as a physical layer. It has one master or one controller, which is in my case a PC or else some intelligent controller device, for example a DJ panel. It has a number of slaves, and a slave is for example a RGB light or a movable light. So in my case for an RGB device it has 3 values that it can use, an R value, P value and a G value. So in DMX land every set point or every value is a byte, which is really simple. And all the host is doing is send the same format of data at the update frame rate. For example, 30 frames per second. So 30 times per second it is sending essentially the same data or same format of data. Each device on the bus, so each slave can occupy a number of addresses. So for example, in my case, an RGB device, one device would occupy addresses 10, 11 and 12, for example. And you can, in my case, configure that with a push button and a user interface. On some devices you can do it with jumpers. But addresses 10, 11 and 12 mean it looks at the 10th and 11th and 12th byte in the data stream for every packet and ignores the rest. And in my case, for example, it uses the 10th byte for the red intensity, the 11th byte for the green intensity, and the 12th byte for the blue intensity. And that's basically it. It's very simple to use, very simple to configure, and I like it a lot. It's very simple. One thing I'll say with the RS485, the wiring and polarity is a little bit difficult, or at least seems a little bit difficult, depending on what you read or who you listen to or how things are explained. So depending on which documentation you read, one wire is the positive one and one wire is the negative one, but which is seems overly complicated. So, or I'm too stupid, of course, it can also be that. What I might do in the future is make resistor jumpers on a PCB, so in case I screw up, or in case 99 out of 100 people think I swapped the polarity, I can fix it using resistors jumpers. So it's not the ideal fix, but might even do that. As a DMX controller or master, I use a simple laptop with a USB to RS485 dongle or cable. I think you can get these from, for example, FTDI. I guess on a number of companies make these. You can get expensive one or simple ones. It's up to you. I guess they're all pretty much the same. No idea. And for software, I use QLC Plus, which is, I think, Qt Light Controller Plus. And it allows you to very easily create a so-called universe of DMX devices. Universe, I think, is a collection of all devices sitting on one bus. And for example, I can connect 4 of my VGA generator devices on one bus and each configure them to have different addresses from a master's point of view, and then just generate colors for all of them. And that works quite fine. I think the software is quite well documented, and it has videos explaining different areas of the program. So I suggest you take a look at this. It's a really nice piece of software, I think. So it may be interesting for you. As for pretty much every PCB here, there was failure involved. Now in this case, I made a silkscreen text with a pinout of a connector and jumper settings. But this text ended up under connector, so it was not actually readable. So defeating the whole purpose. So I suggest not doing that for a better user experience. There's also a little tip I picked up from another PCB I saw. That was if you have room on the PCB where no components, or for example on the underside, if you can afford silkscreen on both sides, maybe it's interesting to put a little square, a little rectangle of silkscreen, just white background, on whatever color your solder mask happens to be, and you can write on it with a black marker, for example. So in my case, these devices have an address. You can configure it, but you cannot easily see it when it's operational. So you can write with a black marker the address number on the device. You can simply look at it and say, hey, this is device number 2 or something like that. Maybe it's a tip for you. One thing I was a little bit worried about with these toy grade devices I made was the effect of different ground potentials depending on where you measure within a building or within a room. So for example, if you would use a different electrical outlet, if you would measure the voltage between the protective earths on both outlets. Because I think such a difference could cause noise on a signal going from one device referenced to socket 1 in a building to another device referenced to socket B in a building. And also it can cause current to flow where I don't want it to flow. For example, in the ground wire of my network cable. I don't really want that. So together with what should we call it? The CBA engineering backbone, or the CBA expert think tank reserve team. Let's say that. We did a little bit of calculation. So how much can this potential be within one building? I'm not even talking about different buildings or 1 kilometer of network cable, just within one building. Now, all buildings here in this country have, all electrical installations have an RCD switch, which essentially shuts the power off in case the current through a protective earth, the cumulative current through the protective earth wiring in a house is bigger than so and so much milliamps. In this case, I think 30 milliamps is a reasonable value for an RCD switch. To be honest, I have no idea what standardized values are. 30 is quite common, I think. So if you do the math, and if the building's installation uses 2.5 millimeter square wire, 2.5 millimeter square means about 7 milliohms per meter, or let's say 1 ohm every 10 meters, which is not a whole lot. So worst case, if you have a building installation spanning 100 meters, and there's the maximum current flowing in that installation wire, in that ground wire, just not enough to make the RCD trip. So let's say there's 29.9 milliamps flowing. That would cause a voltage difference of only 21 millivolts, let's say 20 millivolts between the worst case outlets in your building, which is really not interesting or not relevant in my case. 21 millivolts is fine. I can tolerate that. That's not enough noise to cause a problem. That's not enough voltage to cause a significant current in wiring I don't want to carry current. So I think that's no problem there. Now another potential issue I'm not really sure about yet is the effect of magnetic induction on ground loops through big equipment, for example, or lightning. In my case, this device I made is connected to protective earth through the VGA connector shield, through the VGA monitor, through the electrical outlet, and on the other side is connected to protective earth through the data cable, because I carry data and power through the data cable. Eventually that power comes from some device which is probably earth referenced. So there's a ground loop right there. Now I have no idea if you I'm asking for feedback here, so if you are electrical installer or professional guy or girl who does this for a living or something like that, or has clue about this, how much the effect of big industrial equipment or even smaller equipment is on magnetic induction in ground loops, or what the effect of lightning is, please write in. Please let me know, because I have really no clue. I have no experience in this area, so yeah, let me know. Well, if that didn't put you to sleep, here's 3 smaller projects I made for myself, electronic projects. And by the way, listener, remember that you are in control, so you can send feedback or send comments if some sections or some topics are really not interesting, so please let me know. So remember, you are in control, just send feedback and everything will be okay. Not just are you in control, but I think you're also responsible for whatever happens on this podcast or doesn't happen, so just so you know. Now, first thing that I made was a Christmas decoration. What I did essentially was bend a copper rod into a star shape of about 20 centimeters diameter. In the past I made a 32 channel LED driver board as a small square PCB about 4 by 4 centimeters. I put that in the center of the star shaped. Then I soldered, I think 30 or something like that, LEDs to the star, to the wire, to the bent copper wire at certain intervals, and then soldered wires from the driver sitting in the center to each of the LEDs. Display a nice effect to be put in front of the front window of the house. And the thing here is that you can see through the decoration, so that's nice. You can put something at the back and it's transparent, so you don't even see the wires going from the center PCB to the star. Those are way too small to see, so that's nice, looks nice. The next thing I made was another light decoration. In this case, a thin 10 centimeter long PCB with a number of LEDs on it. Now, the idea here was to shine light into the edge of a transparent acrylic sheet. And if you engrave, for example, using a laser cutter, an image into that sheet and shine light into it, into its edge, then you will see that engraved image light up. It's quite a nice effect. It's not very new. I think I saw someone at the local hackerspace making something like this with a logo. It looked quite nice actually, so I thought, why not do this as well? And instead of one sheet, you can stack sheets and shine different colors into each sheet, effectively making a multicolor image if you overlay the images in each sheet a bit cleverly. So that's what I did. I used two sheets. I think you can use a whole stack of acrylic sheets, but 2 is quite enough. And what I did was make a base with the PCB sitting in that base, shining upwards, and into that base you can stick pairs of acrylic sheets. Now the idea here was to be able to make a completely different decoration by simply taking out the existing sheets and placing in new sheets with new images on them and new shape, and so you can make an existing decoration look completely different with relatively little effort and little cost, because these sheets really cost nothing and laser cutting is not that doesn't take that long. So maybe it's an idea. I'll post let's see, I think an animated GIF again in the show notes of that, and maybe a picture or something like that. Maybe it's nice for you to take a look at. Now the biggest failure with this PCB that I had was related to the LEDs. I think LEDs can be hygroscopic, which means they tend to suck up moisture out of the air. Now if you buy LEDs from a respectable vendor, they usually come in sealed bags with a desiccant. It's like moisture sucking pellets in them, and maybe also indicator card as a chemically coated card telling you by means of colors how dry or how moist the components are. And depending on what the card is showing you, you can bake them at, for example, 60 degrees Celsius for 1 day to get rid of the moisture. I didn't do that, foolishly. And because I bought these LEDs from like the local hobby store and I didn't pack them properly, which is not a big deal, but I should have known better. I should have baked these components for 1 day. I didn't. Simply put them in a reflow oven, and the result was that a lot of them had cracked lenses and a lot of them didn't work. So I had to redo that. It was a stupid mistake, maybe relevant for you as well. Last topic of this episode is another small board I made. It is a fancy version of a hack I made earlier to automatically switch on or off USB powered devices, such as light decorations. In the previous light decoration I made a hack using an LDR, where the decoration would switch itself off when it sensed that the living room light was switched off, and it would switch on if the living room light was switched on. So instead of doing that again and again for all USB stuff, I decided to make a small adapter board sitting in between, for example, a USB charger or a USB power adapter and a USB powered device. So it has 2 USB connectors on it, and basically consists of an LDR and a comparator and a P-channel FET, and it switches off whatever is connected to it when the light level becomes too low. So that's how it works. Now a friend of mine pointed out that sometimes you would want it exactly the other way around, so you want the decoration to start working when the living room light goes off or the environment light goes off, because it looks nicer in the dark. And with this board, because I didn't use any intelligent components, it's a little bit difficult. You can use resistor bridges, for example, to choose between to choose behavior when you assemble the board, but it makes me think maybe this time I wanted to avoid using a microcontroller because I do that a lot, but maybe next time I just put a microcontroller in anyway, a small one, and that makes changes like this a whole lot easier. And also controlling the dim levels and so on. Now I have to take off resistors or change resistor values or something like that. While using a microcontroller, you can just use the software. You can just change the software and that's it. So doesn't cost a whole lot, and it's not like I make 10,000 of these, so I think next time we'll use a microcontroller again. Oh well. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening, and goodbye.